Okay, hello everybody. Welcome back to the second session now of this Somnia Agentathon. This is the first workshop of the series after the launch, which happened a couple of days ago now. And we're joined by George, who is an applied AI engineer at Improbable and part of the R&D team that developed the Somnia Agents platform. This is going to be a 45-minute ish, give or take, presentation, a bit of a run through and a workshop, and then we'll move on to some questions. But if you guys have any questions throughout the entirety of this workshop, then do just drop them in the chat. And let's get the chat going anyway now. Let us know where you're joining from. And I see we've had lots of people creating projects already. So that's great to see. Let's keep that going. If you guys haven't started creating your projects, then let's do that now. The first checkpoint is in under a week now. I think it's in midweek next week on a Wednesday. So you need to submit. It's very basic information for this first checkpoint, and all information is on the platform. So just make sure you are aware of this and ready to submit something when it comes to it. Without further ado, I will hand over to George, who will be talking about how to build on Somnia.
Cool. Thanks, Charles. Hey, everyone. Today we're going to go through just a bit of background about what Somnia agents even are, why you'd want to use them, how we can get started with them, what the purpose of why we develop them is, and what makes them different to some of the other EVM chains, why they make Somnia a really cool place to be building this stuff. As we go along, if you've got questions, please chuck them in the chat. Anjali and Matthias and Giles can be triaging questions, so they can stop me. It's always nicer if there's a bit of back and forth than me just sort of rambling on for ages. So great stuff. Somnia agents. So I should also say, I'm George. I'm a developer at Somnia. My job was part of the team who developed this originally and have been putting this together along with Matthias, who's on the call, and some other people. So starting with the problem, really, what's the problem is that EVM contracts are a bit of a black box. We can't get information in and out of them from the real world. This is sort of by design. They're deterministic. That's kind of what helps make them trustless and mean that we can execute them in distributed manner, which is part of the strength of why blockchains work in the first place. But it does have some drawbacks. Those drawbacks are, it's really hard to get information from the outside world and get it on chain in a way that is trusted. So they can't do things like fetch information from an API. We can't use smart contracts to call language models. We can't get them to go to the web and find out information for us. And we can't get them to interact with things like webhooks and emails, push notifications. That's kind of a limitation of all current EVM blockchains, is that that's a difficult thing to do in a way where it's trustless. So how would you do this at the moment? In traditional EVM chains, you have two different ways. You could use an Oracle network. This ends up meaning that you have to kind of have lots of different maybe tokens, different accounts, different licensing agreements with all these different platforms that you'd want to get information from. And you'd have to stitch them together yourself, sort of decide where you want to be getting different bits of information and then loading that into your contract. The other way you can do this is you can maintain your own backend off-chain and have a server that's sort of sitting there watching stuff happening on-chain and posting information on it. The difficulty with that is you become a single point of failure in your system. You're then the operator, and then you've got to maintain uptime, and you've got all of that to worry about. So what have we done sort of differently here? Is we've developed this idea called Somnia agents, which are decentralized sandbox compute containers. So the idea of this is that we run a network of nodes. On those nodes, you can run a container which does a task. It might be calling a language model. It might be going to the website to find some information. It might be calling an API. And we run those as deterministic nodes, and we spread those out so that everybody runs the same process. And then we get consensus on the result of those processes before they're posted back onto chain. So we have off-chain compute, but then the consensus of what the outcome of that compute is on-chain, and then we can then trust that not just one single actor is able to influence the outcome of those requests. Similar way to Byzantine fault-tolerant nature of networks in general. So yeah, blockchains are ordered and the world is chaotic. So how do we bridge the two? We need a way of having a trusted on-ramp for information. So to bring it off-chain, on-chain in a structured way. Let's see. So that was kind of the motivation and the basic concept behind what Somnia agents are in a nutshell. So what does that look like? At the top level, you invoke an agent and your request goes off to a number of nodes. Depends on your request. You can decide how many nodes you want to process that request. Each one of these nodes will run your job, your process, fetch that piece of information for you, and then we'll post that output back into a contract which checks the consensus of those nodes together. So yeah, that's how we then find this value here, which the consensus value, which is then agreed upon by all the nodes that are contributing to that. That then gets structured into an ABI response and posted back into your smart contract. So at that point, you can trust that the response that's come back has been validated and run by all of these different members of the consensus network. Each node also creates a receipt, which is a kind of audit log of exactly what it did during its execution. So you can go back and debug and sort of understand exactly what happened each step of the process. If you want to drill down into why different values are coming through or why it's come to a certain conclusion. So that as a high level is what we're doing. It's quite simple, but it's quite powerful in how it works. Here's an example of sort of how that looks in practice. You can see here on the left a load of different agent runners who are selected from validators who are validating Somnia network. You can see as requests come in, what we're doing is electing a subcommittee of those validators or of those agent runners to process the request. So there's 8 at the moment on this chart. Each request is having 3 people elected to be the people to process that request, and then they're posting their response back to chain, and we're checking that they all agreed on the output. So yeah, that's how that works, and that gives us this sort of distributed nature of the system, which is really cool. So what does that actually mean in practice? We've got 3 different base agents at the moment. The idea of Somnia agents is it's an ecosystem that will grow, and we will continue to add new agents as and when there is a need to have different types of things happen on this network. We may also, even down the line, open this up so that people can contribute their own agents to the system. But we're kind of starting out small with just 3 of these agents. And we have the JSON API request one, the LLM inference, and the LLM parse website, which I will kind of drill down into as we go through. So yeah, starting with JSON API request, you've got 6 different methods you can call. It's basically just pulling different types of data from APIs. Pretty simple. You choose what URL the API is on, the selector, and then in the case of numbers, you choose how many decimals you want coming back. So yeah, this is useful for things like getting price feeds onto chain, looking at sports scores, weather, anything that's already in like a structured API. You can go and fetch that, select the specific value you want out of that API response, and then return it back to your smart contract to use it in whatever you want to do on chain. So that's the JSON API request one. Second one, LLM inference. And it's a bit more interesting. What this is doing is letting us make just a standard request to an LLM. So stuff we've seen from any LLM service. We've got prompt, we've got a system prompt, and we've got a chain of thought Boolean, which turns on or off thinking. We can also send a set of allowed values. So this is useful if we want to do things like classification. If you want to send approved or denied as the 2 values that it can pick between when it's inferring the string, it can classify different data or approve or deny, or I don't know, set a category for something, or all sorts of different uses there. We do the same thing with numbers, so we can use the LLM to give us a number output. So we could get it to do some simple maths. We could get it to count the amount of information in the request, or all sorts of different, anything that has a number output. We could use that for. On the infer number, we can set a minimum and a maximum value as well for the number that comes back. Then we've got some more complicated ones like infer chat, where we can send a whole chat thread with messages and roles. So user and system and the conversation between them, and it will generate the next message in that chat thread. And then infer tools chat we have, which is a more complicated version of that also has the ability to return tool calling responses so that you can use it to actually take actions in your contract. So for infer tools chat, you could imagine this could be used to let the LLM drive decision making that then the output of which actually happens inside your contract. So maybe it moves some money around or some tokens around. It could change settings. It could do whatever you wanted within the contract, and the actual brain is then offloaded to being the LLM. I was going to just open up this other tab. So here's an example of an interface on the Somnia agent site for making a request. This site, you can go in and make example requests against all the different agents, which we'll look at more a bit later. But as a quick example, I can go in here and say, what is the meaning life? We don't need a system prompt or chain of thought for this. And then we can actually launch the request. You can see it's encoded it as bytes that get sent to the agent, confirm that. And it will then select a subcommittee from the node runners, run this request. And in a second, it should come back. And this is going off running across the network, across all the different ones. And there we go. There's our response. And here's our output. It's quite long. But they've all generated exactly the same response, which is a really cool part of this system, is that we've sent this request to all of these different node runners and all of them have agreed on the same output, which is quite cool. So let's run that again. Okay, so from here, the last one we have is the LLM parse website agent. This is probably the most sort of complicated one. So just what this is doing is going off to the internet, finding some piece of information from a website, and parsing that out from the website and extracting some information and putting it on chain. So where this is useful is if you don't have a structured API with some information in it, then this is great for going out and just finding information from the messy websites of the world, unstructured, and pulling it out and putting it into a form that we can put into a smart contract. So this can go and find any string or any number on a site and pull that out and post it back to your smart contract for you. So parameters for this, we have the key and the description of the string that we want to extract. So, for example, that could be, the key could be winner, and the description could be who won the election or winner of the election. And then the options there, you might put the names of all the candidates that it's picking from. The prompt would be who won the 2026 election, and the URL could be the BBC News article with the election results on it. We could then run this request and it would go and fetch the information about who won the election, pull it and post it back on chain. We've also have the ability to use resolve URL. What that does is lets us search inside a domain for pages that are relevant to our query. And the number of pages value says how many of the top results should we search within. So if we say 3, then it will essentially search inside that website for your query, look at the top 3 results, and then search within those to extract out the string or extract out a number and post it back on chain. The last one here is confidence threshold. So one of the things we ask the model to do is to tell it how confident it thinks it is in its ability to answer a question. And then we can say we are only interested in answers that have over this confidence threshold, otherwise revert the request. So that's extract string, exactly the same for extract a number, except it pulls out a number instead of a string. And we can set a min and a max value for that number instead of this options array. Were there any questions up to any of that point? I've been going.
We have a few questions, George.
Yeah, sure. Shall I do some of those now, or is that useful? I can read them if they're in the chat here. Yeah.
The first one is around tree graph, whether the agents can look at the chain themselves or whether they do thinking before.
So the actual agent runner containers themselves are fixed and run a pre-compiled agent runner code. But you could imagine that in your smart contract, they could be dynamic in some way, that they can start making different decisions in the smart contract and sort of changing their own behavior in a way there. So yeah, maybe that could work. To look at the chain themselves. So you could also subset. Sorry, I'm just reading. So yeah, you could definitely one of the sources you could be reading could be on-chain data as well, and then using that data to pass it to the LLM to make some decisions. So you could say, from these prices or this activity, what should my next decision be in a trading bot or something like that. The execution receipts are definitely publicly accessible. So yeah, anyone can see any request you make on this network. That's a really important point, is you shouldn't put anything sort of secret in here. It's a public system. You're sending these requests out and they're coming back and being processed in public. So just seems. So to be clear, each of the validators can run any of the 3 different agents themselves. So they swap the container between running JSON fetch, LLM parse website, or the LLM inference agent. So all of the validators in the network have the ability to run any one of the 3 agents that we support. Question around handle blockers like Cloudflare. Yes, this is something that we've put some work into, sort of running these agents through proxies and other things to try and avoid getting them blocked when they're trying to find information from the web. This also helps having multiple agents running at once, because you have some redundancy. Sorry, multiple agent runners running at once, because you have some redundancy in the system to be able to deal with some of them not coming back with requests. So I could also just going to quickly show what the receipts look like here. So here's an example of a receipt that's come back. So the question, this is for an LLM parse website request. The prompt here was around finding out whether Sam Altman had testified in court in his trial against OpenAI. And so we can see, we get all sorts of information here back. So at the top, we can toggle between the 3 different receipts for the different runners who ran this request. And we can see the differences in how they processed it. You can see for this one, they all came to the same conclusion, that the answer was yes, that Sam Altman did testify in the court case. And then we can really drill into exactly what happened. So it started off with, this was the request that came in. We fetched one web page. We can have a look at what the HTML was for that web page that came up. We can then converted that web page into Markdown, so we can look at the Markdown that was generated. And then we can see that was then passed to the extract step, which is the LLM step. And this is what came out of it. We've got some reasoning about why it came to its conclusion, the number of tokens that got used, the temperature or the settings, what the actual output was. So in this case, yes. And it was 100% confident in its answer. And it said that it was true, that its answerable is true. We've also got the chain of thought thinking down here that we can also inspect if that's useful. And then finally, the output that was sort of agreed upon by all the runners. So for every request, you can really drill into exactly what's happened and what the different node runners were processing when they came to. So yeah, this LLM parse website is really useful for sports and esports outcomes, anything with sort of tabular data online, looking at leaderboards, trying to find information from those, doing like sentiment analysis on news websites, prediction market things. Basically any data that's on a web page that is not behind an API, it's really useful to use LLM parse website for. One of the underlying kind of principles of this is this deterministic language models. Under the hood, then all of these agent runners are running their own GPU, which is running a model on which we have pinned model weights, the same runtime, the same frameworks. Everything's identical across all the runners, which means that when they take in a request for an LLM inference, then they will give byte identical output based on the same. So as long as we send exactly the same prompt, temperature and seed, then we'll get exactly the same response out. This is something that isn't the case for a lot of LLM providers. So OpenAI, Anthropic, if you send the same request to them over and over again, you're not always going to get the same response. The reason for that is that they optimize for speed and throughput. There's stuff to do with how requests are batched together that causes there to be slight differences in how requests are processed, which in most cases is fine. But if you're trying to get to a point where you can agree on some value and post it back on chain, then that's no good. So we've gone for this batch invariant deterministic version of a language model, which means we get around that problem. It also means it's deterministic under whatever load we put it under. So that's one of the kind of key building blocks underneath Somnia agents is this idea of deterministic LLMs. That's why it's interesting. So this maybe answers one of the questions that came in earlier, was about, so your DApp at the top, you create this request which goes into the Somnia agents platform. That request is then sent to however many agent runners you request in your call. And each one of those has a sandbox that can run either JSON fetch, LLM inference, or LLM parse website. So they swap under the hood between the different containers for the different sandboxed agents. That is then sent through a metered proxy. Any requests that go to the outbound internet, we are checking how much bandwidth they're using, how many times they call language models, etc., in order to be able to make sure we're charging the right amount for the request. But this happens n times, as many times as you want for your request. So each node runner runs this same process inside. Then once it comes to consensus, then submit the response back to the platform. Here we check for consensus, and that consensus is then sent back to your app. Where do these agents actually live? Each Somnia node operator runs agents themselves on their own provisioned hardware. This gives us some kind of independence of the system, so there's no single point of failure. It's distributed. We also on chain we have the ID of the current version of the node runner. So when they make requests, we check that everyone's using exactly the same version of the code. And they can pull the latest version down. They check on chain, are we using the right ID? If it's not the right ID, they'll pull the latest version and run it. And as I said, everyone is using their own dedicated GPU. And that's running the deterministic LLM. Is that another question in there? Quick question around a bit of information around the kind of the cost of this. So everything's metered in SOMI or in STT if you're on testnet. For the time being, the 3 different agents have just got a hard-coded cost per invocation. And there's some information on this slide about how you use those costs to work out the total price of your request. So for the number of runners you want to run a request, you have to multiply the cost of each invocation by the number of times you want that run. And then there's also some extra money in there spent on covering the gas for the transactions. So the way it works is you send basically the cost of the agent runner job to be run plus the gas cost, and that gets sent out to the runner gas, paid to them, the subcommittee member, to actually execute the request, and then anything left is sent back as a rebate back to your smart contract. That means that runners are able to earn a small fee, which helps pay for the upkeep of running an agent node in the first place. Just having a look at these questions. STT, yes. There should be a way of getting more STT through the DevRel team, which is something we can talk about later on. In terms of testnet, no, it should be almost identical to mainnet. Everything should run the same. We're also running a committee of about 8 runners on testnet as well, so you should get the same behavior. The only thing is we may run new versions of agent runners will run for a time on testnet before we migrate to mainnet. So that's the only difference. But from the user's point of view, it should be the same. Cool. So how do you actually call these things? There's some information here about how you make the request. So this is Solidity code. It's pretty simple. Within your smart contract, then you just need to call create request. Create request takes in the ID of the agent that you want to make a call on, the callback address, which is the address of your contract that you want to receive the response, the callback selector, so the function selector that you want to receive the callback, and then the payload is the actual request information that goes to the agent runner. You then also need to attach the right amount, so payable with the value that is computed by the formula on the previous page. You then also need to implement handle response. Handle response is what would receive the callback from the agent runner. So you'll get the request ID, and then also the response that was generated by your job. You can also check the status of the request that comes back in the response, so whether it succeeded or not, and the reason why. So yeah, that's all you need to do. So this is an async process. You make this request, and then you then wait for it to come back and call back into your contract. There's also a kind of a more advanced version of create request. The difference with this one is that it allows you to specify the subcommittee size. So by default, I think we use 3 subcommittee with a 2 threshold. If you want to have a custom threshold and a custom size of committee, then you can do that using the advanced request, and you can set your subcommittee size and threshold yourself. We also have different types of consensus that you can ask for. There are certain types of fetches where you aren't always going to get exactly the same response from the different runners. For example, if you try and fetch Bitcoin price from an API, even a milliseconds of difference between the different runners making the request might mean you get very slightly different prices. In that case, then you might want to take all of the responses from the runners and then average them yourself in your smart contract, rather than relying on just one value coming back that's got consensus on it. So that's why we have these different consensus types. So you can either ask for, I only care about them all agreeing. So this is useful for things that aren't going to change. What football team won a match? Who won an election? A yes and no answer about some question. Whereas if you're asking for more continuous data, what the temperature is, what, if it's what the price of something is, it might be better to use the threshold one, where you can get all of the responses back, and then you can decide how you want to aggregate them afterwards. Here's some information about just how you package up requests. So first, calculate the deposit you're going to pay. We set the URL, and then here's an example that I'm going to use the JSON API agent. The callback is going to be to this contract that I'm calling from, and the selector for within this contract. And then I'm going to encode the payload with the URL, the selector, which is bitcoin.usd, and then the number of decimals. So it's just an example of how you can set up a simple JSON fetch request. Each agent has its own ABI. So when you're encoding that payload, then you need to set up the payload depending on the type of agent. So they take in different parameters. Should say that all of this stuff is documented in real detail on our docs website, which I will link at the end. If people are kind of moving too fast with some of this, you can easily find all of this information on the docs. Cool. So then how do you handle the response? So this is my callback function in my contract. It takes in the request ID, the responses array, status, and the details. First thing we're doing here is just checking that the request did come from the agent runner platform. So you can't have someone spoofing your requests by calling the same function externally. So we're checking the address. We're checking that the request ID was in a mapping of known requests that have been made. After that, we delete the request from the mapping. And then here we're just emitting an event saying we received this price, and we're setting the latest price in the contract to the value that came back. It's super simple. There's not doing any logic in here or anything, but at this point you could do all sorts of things. You could say, if that latest price is above some threshold, then execute a trade on a DEX, or unlock a vault, or all sorts of different things you could do with that once you have that value in. What comes back from the runner is these different, so like I said, you'll get a status of how your request went. Usually it will be 2, which means everything's fine, succeeded. It could be that it failed for various reasons. It might be that the page that you've requested didn't exist. The API failed for some reason, in which case you'll get back a 3. So yeah, that's what the response status is. And then we've got inside the response array, you'll see what validator ran it, what the result was as bytes that you can then decode, the ID of the receipt, if you want to go and look that up, the timestamp, and the cost that it charged you for as well. So yeah, that comes back for every request. You'll get an array of these responses, and it will tell you exactly what happened. So putting that together as a price oracle, it's a bit similar to the one we just had. So we're going to set it up that on testnet, we've made an interface for the platform, and then we're calling first get request deposit to find out how much we need to pay, and then we're calling create request on the platform and sending this payload to fetch the USD Bitcoin price. Another question on there. So yeah, that's just an example of how. The other small thing here is that if you want to be able to receive rebates on your process on your requests, then you need to implement the receive function in your contract as well, so that it can call back to pay you back any excess budget that you sent that wasn't used in your request. Yeah, as I said, this runs on testnet and mainnet. So for testnet, feel free to throw away. You can use this whilst you're experimenting with stuff. You can use a faucet to get STT, or the DevRel team can hand out STT. Here's some like the URL you need, the contract, and there's an explorer specifically set up for testnet to explore the receipts. On mainnet, then yeah, same deal, but you're using real Somni. So on this one, you want to be more deliberate with what you're doing. Make sure you're using this for real world usage rather than just experimenting. Other than that, they should be exactly the same. So you just point at a different contract, and there's a different set of URLs. So quickly back to the receipts. For JSON fetch, you're going to get back the request, the HTTP request, and then it encoded. So it's just, you'll see each step is kind of laid out in the receipt. For the LLM inference, very similar. You'll have the request detailed, the inference details, so exactly what was sent to the LLM, and then what was encoded back. For the LLM parse website, you've got a much more detailed or kind of more complicated step. So first one is request. If you've asked it to resolve the URL, then it will show you the search step, what URLs came back from that. Then the fetch step, which uses ZenDriver to kind of try and fetch the data from that page as a HTML document. What happened in convert stage, so the HTML being converted into Markdown, if there were any errors there, exactly what Markdown got extracted. And then lastly, the LLM step, which takes that Markdown and tries to extract some data outside of it. So you'll get back a receipt that's a JSON file that details all of that, exactly what happened for your request. If you want to be able to get to receipts, you can get them from this API, and you can fetch the receipts yourselves if you want to use them in front-end applications or show them inside a UI. And here's an example of how you would do that. So use the base URL receipts.mainnet.somnia.host, and then you just need to send your request ID and the contract address, which is just the agent runner contract address. And then you can then log them out or show them in a website or whatever you want to do with them. Just reading these, sorry. In the receipt. It should log everything in the receipt in terms of the system prompt and the prompt itself. I think one of the principles here is that everything you're doing is completely public. So and that means it's transparent and easily auditable. Your users can also see exactly what's happening. It's very open. So there isn't really any way of hiding a system prompt away from people. Everything that we do is public. Does the LLM trigger the parse itself, or is the code somehow doing the parsing? So it does follow. It follows the same when you're using the LLM Parse website agent. It will always follow the same steps. It doesn't do it in a kind of agentic way where it has the ability to do web fetching calls. It will just always go to the website that you've asked for, extract that information as HTML, convert it to Markdown, and then pass that to the agent to try and extract the information from. So it's more of a kind of predefined steps that are always followed. We are looking at also experimenting with more kind of dynamic agentic ones where they can make the decision about what they want to do next themselves. But for this first version, then they're a bit more structured, if that makes sense.
I think we have another question from participant which we missed, George. Can you chain multiple base agent calls within one contract function?
You could, yes. What you would need to do, because they won't, not within one function, because you're waiting for the callback to come back. But what you could absolutely do is have the callback handler from the first request could then call another agent in itself and pass that information on to the next step. So you can absolutely chain them together however you like. You would just need some logic to handle the callback, take whatever data came in that callback and pass it on to another agent. So yeah, that opens up all sorts of things you could do with sort of routing requests through. First go and fetch something from an API, depending on what comes back from there, make a decision that again gets sent off to an LLM that comes back and do something else. So yeah, it makes it very dynamic in that way, using it that way. Okay, so just going to just quickly some debugging stuff. So yeah, you'll see like error codes sometimes on the receipts. We have retries, but sometimes they are exhausted. So you may be trying to hit an API that doesn't exist, or just your request is wrong, in which case you'll get you might get 49 or 500 errors. Then yeah, the main one that you might see from some of the LLM Parse website is 422. Which can be that it's just not an answerable query. For example, if you ask who won a match, a football game, and the match hasn't happened yet, and you ask the agent to try and work it out, it just isn't going to be able to answer that question because the information doesn't exist. So in that case, it should return 422, which just says this isn't answerable given the current URL and the current context. We also have that same 422 if the confidence score is below the threshold you've set. So if it's not sure enough, then it will fail the request. You might also see issues with pages not being available, so we can't get past bot detection or other paywalls, etc. That might be another reason why a request would fail. So yeah, it's a good idea to kind of experiment with your specific use case on testnet and try and make sure that you have a system that is solid before you put something into production. I'm just seeing this most recent question. So the agent has no room for thinking itself before parsing and thus being made non-deterministic. Yeah, so you're going to need to be careful with any internal secrets because they will be public. But you could have an agent call in which you give it 5 or options as outputs. So to choose between 5 different actions, for example, it could be even just 2. It could be you ask the agent, should I buy or sell, for example. You send it a load of information. It maybe scrapes from a website the sentiment of some news article, and then based on that response, it sends back buy or sell. And then in your contract, you look at that response and you execute different logic based on that. That's one example of something you could do. The agent, there is some secrets within that, but there's no ability for you as an external user to kind of put new secrets into the agent. They have some secrets to do with the proxies they use and the LLMs they use and stuff. For now, there isn't a way to do kind of authenticated APIs or anything like that. Something we're looking at. Cool. So that's sort of the end of like how you actually call these things. I thought it would be useful to give. We did an internal hackathon a few weeks ago, and I thought I could just highlight some of the projects that were made by our team to give some ideas of stuff, the kind of things you can use agents for. But if anyone else got any questions before I move on from the sort of Solidity part. then chuck them in, give it a minute, and then if not, I can run through these. No. Okay, cool. So yeah, 5 projects from the Somnia hackathon. So the first one that was really cool was someone made on-chain D&D. So this was a completely on-chain dungeon master where you could play a D&D campaign where every decision about what happened next was being made by an on-chain distributed language model. It was also used to generate the initial stats of your character, the names, everything that was generated within it was all done through Somnia agents. So this was a really cool example. You could then type in what you wanted to do next, and the LLM would make a decision about what the next thing should happen within your D&D campaign. This one was one I did, which is called Rainy Day Fund. It was a bit silly, but the idea of this was, could you lock up your Sommi and only release it on a day when it was actually raining? So here, then I pointed it at the BBC weather in London. And when I clicked to try and open the vault, then it would actually go and check the weather for real. And if it was raining, then it would let me get my Sommi out of the vault. Which was just an example of how you could use this to gate a vault of tokens. Very similar was this one as well, which was a game called The Sphinx. The idea was that you paid Sommi every time to try and convince the Sphinx to give you what was inside the vault. So there was a vault that was accumulating STT, and you had to give it a reason why you were worthy of receiving the money. If it didn't like your answer, then it kept your deposit and it would get put into the vault. But yeah, you could eventually convince it that you were worthy, and it would then release out the Sommi to whatever wallet was currently connected to it. Just having a look at this. Sorry, does the Somnia agent have access to X402? X402 is definitely something we're aware of, not something we have in at the moment, but it's definitely on the roadmap to start looking at how we do some of this kind of authentication stuff with payments and other ways. So yes, definitely something we're thinking about. Cool. Another one I did here was like a Tamagotchi. So here you could name your pet and it would go and generate a bio, like a story for it. And all of that was happening through Somnia agents. So it would create a character, its backstory. We also had an image generation agent at one point, which might come back at some point, which was also used to generate these images. And yeah, so you could ask it, then talk to your pet, and it would respond using Somnia agents consensus. So I could send it a question to say greetings. And this was using the infer chat agent. So you could send the whole conversation up to the point you were at. And again, it was responding to me there, all using Somnia agents. And then this one was really cool. This is like a kind of word game. The idea of this was that every day the contract would generate a new word, or using the Somnia agent infer LLM inference agent. It would pick a word, in this case thumb. Then players would go in and try and work out what would be a good acronym for this word. So they would put in their acronym, and it would then send it off and judge how good their acronym was using an agent and saving it back on chain. And then at the end of the day, the person who had the best acronym won the prize pool. So this was quite a fun one that showed how you could use the language generation capabilities of a Somnia agent to build something kind of interesting and completely autonomous. I think that's one of the bigger picture things that these agents let you do, is just completely hands-off autonomous systems that live on chain, which is actually super interesting. We were talking about this at the time, that you could imagine building a trading bot that there was actually no way of stopping it. Like if it was profitable, it could earn money, pay itself Sommi, and then that would be enough for it to keep paying its own gas to be able to continue operating on chain without any human involvement at all, which is really cool. So yeah, that's another example there of I put a couple of things on here of other like examples of stuff you could do with Somnia agents. So yeah, some stuff we've talked about: oracles, price feeds. You could use it for content moderation. So yeah, checking stuff is okay before you allow it to be posted. You could do dynamic NFTs with their metadata and descriptions being driven by Somnia agents. You could have fully autonomous agents talking to each other on chain. AI judged contests, a bit like the previous one. Stuff about tracking flights and freight, other things like that. Obviously, prediction markets, Dungeon Master we looked at. AI generated quest narratives, sort of on-chain gaming opponents, NPCs that are on-chain that you could interact with in games. And some more DeFi ones, so you could have something that it was watching the news for some news event, and if it saw it, then it could trigger you to then sell your assets or buy assets or whatever it was that you wanted to do. That's that. Here's your resources. So the main starting point is just docs.somnia.network/agents. And also agents.somnia.network is the explorer, which also links out to docs. There is also the testnet faucet that you can find through DevRel if you want to get your small amount of STT, but I think there might be more going if people need more for testing this stuff. Look at that, bang on time, pretty much. Any questions beyond the ones we've already had? Then we've got 15 minutes if anyone has anything they want to check. Otherwise,
I think you've answered all.
Nailed it. That's good. There's a couple of things going. Okay, that's the link to the agent-a-thon.
Yeah. That's on us. We'll handle that.
Will the projects you did internally be made public? I can ask some of the people if that's useful. I could put them up somewhere as kind of examples. That could be a useful thing to add to the website. Maybe it's just an example of how people use them. And sorry, if I didn't understand your question, then feel free to send it again, and I can they can send it offline if that's useful, and I can answer it properly. Giles, did I miss anything? What do you think?
That sounds all good. And I mean, if anybody does have any other questions, then we can just chuck them on the Telegram chat. I hope you guys have all joined the Telegram chat. And if you haven't, there's a link for it in the Discord. There's a link for it on the platform page in the About section, in the main body of the text. The Somnia team are going to be present on there. So any technical questions about test tokens, anything else, the Somnia team will be happy to get involved and answer that. So join the Telegram chat is my main bit of advice there. Thank you very much, George, for that workshop. And that wraps up the first workshop. We have our second workshop is at the end of it's a week today. Is the next workshop. It's Friday the 29th of May, and this is going to be talking about how to win a hackathon with Anthony, who is the CEO at Encode, who knows lots about it because we run hackathons for a living, and so I'm sure he can offer a lot of insight to that. The first checkpoint as well, good thing to note, is next week. It is on Wednesday, the 27th of May. I will send a reminder on the Discord with a countdown so that you know when to submit. There's nothing super important that you have to submit for this one. You just need to let us know if you've started creating your project, and then there's an opportunity to upload your CV and your teammates' CVs. But it is still an important checkpoint that you do still need to hit. So if you have something and you are planning on submitting something at the end of this hackathon, you need to hit this checkpoint. Information is on the platform. I will drop a reminder on the Discord early next week. And other than that, any questions? Discord, Telegram. Thank you very much, George and Charlie and the Somnia team. And I'll see you guys all next week.
Thanks, everyone.
Bye.